multiply this series, though, right? So that's not, we can't just relabel that. It is already what it is. So 2 divided by n factorial times 3n plus 1, x to the 3n plus 1. And then how would you finish the problem here? Make it negative. We're still feeling the sting of losing the point from the other test, right? So it is negative, so we must choose the negative in order to match the initial condition. And also y of 0 is what? Minus the square root of k. And then what? Does this, where does this start? N equals to 0 puts a x here, right? When you plug 0 into that, this is 0. And it just gets, more 0-y as you go higher order, right? It becomes like 0 squared or 0 to the 4th power or 0 to the 7th power, whatever. Okay, so my point to you is that series is trivial at 0. And so we just get square root of minus the square root of k equals to what? Minus 1. So for my made-up example, we would just put, if you don't mind me just erasing the evidence here, and because I don't want to write it again, 1. Yeah. Answer. So this is kind of sort of like your problem 115. Now, I think, if I remember right, the higher problem, what do you know? The higher order problems past that, a lot, there's like 3 of them that are just this silly limit thing. So you should do those, right? Yo. Yes, I now remember. What is the remaining trick I still need to share with you today? This one. Although I've been, it's not a trick. It's a technique. Let's see here. You're supposed to say, example 6, is it?
Yes.
All right. Suppose you want to integrate x to the 4th times the sine of, I don't know, x squared, let's say, dx from 0 to 1. And let's suppose we want to calculate that and to some, particular accuracy. You guys pick the accuracy. What do you want to do? Within, let's say within 10 to the minus 4? All right. Okay, so what we do is we trade the integrand for its Maclaurin series. So what is the Maclaurin series here? You've got x to the 4th. In this case, x squared, right? Minus 1/6 x squared cubed plus 1 over 120 x squared to the 5th power, and so forth and so on. I bet that's more than enough. All right. And so what you're looking at then is the integral from 0 to 1 of x to the power 6 minus 1/6 x to the what? 6 plus 4 is 10. I think this problem is going to be like kind of stupid. 1 over 120. You're like, you don't have to convince me of it. Let's see here. X to the 10 plus 4. No, you didn't say that. You guys are just, you're not thinking negative thoughts about calculus. It's just that you're thinking about climbing, right? Just dreaming to get back out there on the wall. Fight the pointless fight against gravity you'll never win. Eventually you're going to come back down. You know what happens to the free soloists? They'll die. They'll die. What? Yeah. Horrible, horrible deaths. Yes. Sorry.
So you asked us to find like the first term that allows you to be within 10 to the negative 4. Do you just have to guess and check?
Yeah.
Like,
Yeah. I mean, well,
puts you at that?
I think you want to do this calculation, this kind of calculation, to enough terms, and you hope you did enough that you, well, the answer to your question becomes clear once we get just a little bit further. So then we integrate, right? So we have 1/7 x to the 7th minus 1 over 66 x to the 11th plus, wowzers, 1 over 15 times 120 x to the power 15 plus dot 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 dot. Fundamental theorem of calculus, part 2, still applies. Evaluate from 0 to 1. But of course, when we plug in 0, we get
0.
Nothing, right? It doesn't even exist. But when we plug in 1, we get 1/7 minus 1/66, right? Plus 1 over 15 times 120. Now I'm starting to feel like maybe I didn't take enough terms. I felt so high and mighty with that x to the power 7, x to the power 11. Like, wow, this is really, it's really awesome. Like, we've really done something here. But now I'm starting to feel bad about this. Now let me explain. So what do you have? The point is, when you work these problems out, when you get to this stage, this is an alternating series, right? But we know how to approximate the error in alternating series, right? We have the alternating series estimation theorem, which says that the error is what? It's the next term, right? So, yeah. So as it stands, if I do 1/7 minus 166, right? And I say that that is, the integral. So if I look at the integral from 1 to 0 of x to the 4th, I should have just given this thing a name. I'm a dummy. Sine of x squared dx. So I do all of that minus this, right? And I look at the absolute value of that. That is less than or equal. It's bounded above by what? The next term I haven't used, right? 1 over 15 times 120. And what is that? If I'm lucky, it's 5 10,000s. Ah! So to answer your questions, then we have to go back and add another term to be sure. Listen, there is another way to do this, which is what? Yeah, okay, so this right here is 0.00055 repeating, right? So I'll just say 5, 6, something like that.
So if we have an extra.
So this is not enough. We have to use all 3 of these. But to support my claim, I also need to know that the next one is actually smaller. Right? So what's next? What did I not get to? So the way to avoid this is to do it symbolically. So you could just as well have done the integral from 0 to 1 of the summation, right? N equals 0 to infinity of minus 1 to the n over 2n plus 1 factorial x to the, 2n plus 5, I think. I probably did that wrong. No, because I need to square, my bad. X squared to the 2n plus 1, what's that? And I have to multiply that by x to the 4th, yeah? So this is what? 2n. 4n plus what? 4n plus 6, right? So if you look at that, then this gives us the sum n equals 0 to infinity minus 1 to the n over 2n plus 1 factorial times 4n plus 7, right, is the integral. What? Did I not? I thought I added the 6. Because this would have been 4n plus 2, and then we added 4. That gets us to 4n plus 6 when I integrate.
You lost your x.
Oh, I integrated.
You integrated and you left out your x when you rewrote it.
Yeah, I integrated, though. I mean, I did the integral. I did all of this. My bad. We're out of time. But So my point is, if you did it in general, you'd get this for this problem. And so then if I ask questions like, what does it take for it to be accurate to within a millionth, then you'd look at like, 1 over 2n plus, the question then becomes, how many n do you have to go to before this term right here, right, is equal to like 10 to the minus 6? I mean, I don't know. Apparently when this gets to be a million, so 6 or 7 maybe? I don't know. Does that make sense? I mean, so.
What if we have extra terms that put it like closer than what you wanted it?
Well, the goal is to take just enough. I mean, that's the best way to answer this question. Yeah. Well, guys, see you tomorrow. Oh, we should have a quiz tomorrow. I know. Tomorrow's assessment day. What? Ah! Son of a gun.